The life cycle of stars, from birth to destruction. Welcome to Understanding the Universe, the channel where we unravel the secrets of the cosmos and bring the science of space exploration to life. In today's episode, we embark on a fascinating journey to explore the life cycle of stars, from their birth in vast, sprawling nebulae to their ultimate fates in the form of white dwarfs, neutron stars, or even black holes. Stars are not just beautiful points of light in the night sky. They are the lifeblood of the universe itself. Their formation, existence, and eventual destruction are responsible for shaping galaxies, creating elements essential for life, and sustaining the continuous evolution of the cosmos. Whether you are a science enthusiast or a curious mind compelled by the mysteries of space, this educational journey into the lives of stars will leave you inspired. So let's take a closer look, beginning at the very start, where stars are born. A star's life begins in a nebula, a vast, cold cloud of gas and dust scattered across space. These nebulae are sometimes called star nurseries because they serve as the birthplace of nearly every star in the universe. But how does a star form from what seems like a scattered collection of particles? The answer lies in the force of gravity. Over time, gravity pulls the gas and dust in a nebula closer together, forming clumps. These dense regions continue contracting under their own gravity, becoming smaller and hotter with each passing moment. When enough material has collapsed, the clump forms a protostar, the earliest phase of a star's life. At this stage, the pressure and temperature in the core of the protostar rise. Once the core reaches millions of degrees, a critical process begins: nuclear fusion. Fusion ignites when hydrogen atoms collide and fuse together to form helium, releasing an immense amount of energy in the process. This energy is what causes the protostar to glow, officially marking the birth of a new star. Not all stars are the same, though. The mass of the original gas cloud plays a critical role in determining the type of star that forms. Smaller masses lead to dim, long-lived stars, while larger masses create the bright, short-lived giants. This mass will also dictate how the star's life unfolds and ultimately how it ends. Once nuclear fusion is underway, the star enters the longest and most stable phase of its life, the main sequence phase. During this time, stars generate energy by fusing hydrogen into helium in their cores. This process creates the heat and light that allows stars to shine brilliantly for billions of years. For stars like our Sun, the main sequence phase accounts for around 90% of its lifetime. The energy produced by fusion creates an outward pressure that balances the inward pull of gravity, keeping the star in a stable state. This balance is known as hydrostatic equilibrium, and it's what allows stars to maintain their shape and brilliance. Not all stars experience the main sequence in the same way, though. Their mass again plays a key role in shaping their behavior during this period. Small stars, known as red dwarfs, burn their fuel slowly, glowing faintly with a reddish hue. They are incredibly efficient and can remain in the main sequence stage for trillions of years. Medium-sized stars, like our Sun, burn fuel at a moderate rate, radiating a bright yellowish light. These stars have lifetimes of around 10 billion years. Massive stars are hot, blue-white, and highly luminous. They burn through their fuel at an astonishing rate, living only a few million years before they begin to die. As beautiful and stable as the main sequence phase seems, no star can stay in this stage forever. Eventually, their hydrogen fuel runs out, and the next dramatic chapter of their lives begins. When a star exhausts the hydrogen in its core, fusion slows down dramatically, disrupting the balance of forces that held the star stable. At this point, the star begins to evolve in very different ways depending on its mass. There are two primary paths a star's life can take. Stars like the Sun, as well as smaller stars, undergo a relatively gentle transformation as they age. When they burn through the hydrogen in their cores, the outward pressure decreases and gravity causes the core to contract. Simultaneously, the outer layers of the star expand outward, creating a red giant. Red giants are enormous, hundreds of times larger than the original size of the star, and their cooler surface gives them a reddish glow. After shedding its outer layers into space, the remaining core of the star forms a small, dense object known as a white dwarf. White dwarfs no longer produce energy through fusion, but they shine faintly for billions of years as they slowly cool down. This represents the final stage for low and medium mass stars. For massive stars, the end is far more dramatic. After exhausting their hydrogen, these stars swell to become supergiants, the largest stars in the universe. Their cores begin fusing heavier elements like carbon and iron in a last attempt to maintain stability. When no more energy can be extracted through fusion, the core collapses under the force of gravity. This leads to a supernova, a powerful explosion so bright it can outshine an entire galaxy temporarily. The explosion scatters most of the star's material into space, but what remains of the core experiences one of two possible fates. If the core's mass is relatively small, it becomes a neutron star, an incredibly dense object made almost entirely of neutrons. If the core's remaining mass is exceptionally large, it collapses further, creating a black hole. A black hole is an object so dense, with gravity so strong, that not even light can escape it. These dramatic endpoints are the final acts in the incredible lives of massive stars. Even in death, stars play a crucial role in the universe. In fact, the aftermath of a star's life is often more important than its lifetime. During their fusion process, stars create many of the heavier elements that are essential for planets, life, and even our bodies. Oxygen, carbon, iron, and countless other elements originate from stars. When a star dies, these elements are scattered across space, either through gentle releases like planetary nebulae or violent explosions like supernovae. This material enriches the surrounding cosmic environment, providing the building blocks for the formation of new stars, planets, and eventually, life. In this sense, the death of stars is not an end, but a beginning. The gas and dust expelled during their deaths mix with nearby nebulae to begin the cycle of star formation anew. The story of stars isn't just about their individual lives, it's also about the larger cycle of creation and transformation that shapes the cosmos. Stars are born, they shine, and they die, but in doing so, they leave behind the building blocks for new stars to form. This cycle keeps the universe alive and evolving. It's this constant recycling of matter and energy that allows galaxies to grow, planets to form, and life to exist. It's incredible to think that the Sun, the Earth, and even our own bodies are made from the remnants of stars that lived and died billions of years ago. Carl Sagan's famous words echo powerfully, "We are made of star stuff." Through this cycle, stars connect us to the universe in profound ways. They are the architects of existence, ensuring that the cosmos continues to thrive. Stars are the beating hearts of the universe. From their humble beginnings in nebulae to their fiery deaths in supernovae, they shape galaxies, create essential elements, and help life itself emerge. Today, we delved into the fascinating life cycle of stars, covering their birth in nebulae, their stable phases in the main sequence, and their dramatic deaths as red giants, white dwarfs, supernovae, neutron stars, or black holes. We also looked at how their life and death spark new beginnings, fueling the endless cycle of cosmic evolution. Stars are more than just distant lights in the night sky. They are the foundation of everything we know and everything we are. By understanding them, we gain a greater appreciation of our own place in the universe. Thank you for joining us on this journey through the life cycle of stars. If you enjoyed this exploration, don't forget to subscribe to Understanding the Universe for more captivating dives into space and science. The universe is brimming with secrets waiting to be uncovered, and together we'll continue searching for answers. Until next time, keep looking up, because the stars hold the story of everything.